Lecture number 2 for the principle of mathematical induction, class 11th, and the last lecture we have started the exercise 4.1 and we have done up to question number 2. Let us take the question number 3. As usual, this statement is given, and in this statement we have the sum of these terms, which is equal to 2n upon n plus 1. You have to prove that it is true for all natural number by principle of mathematical induction. In this question, one or two steps you have to do more, because in the last term we don't have the sum of these numbers, that is 1 plus 2 plus 3 up to n. You know that the sum of these natural number up to n, you know that it is equal to n plus 1 upon 2, and for this you can write 2 upon n plus 1. So one step you have to do more in this question, because the last term is not given in the simplified form. So as usual, you let that this is equal to Pn. Let for n is equal to 1, the left hand side is equal to 1, the sum of one term, and in the right hand side replace n by 1, so 2 into 1 upon 1 plus 1, which is equal to 1 itself. So left hand side is equal to right hand side, so it is true for n is equal to 1. Let the statement is true for n is equal to m, so replace n by m, so it will be 1 upon 1 plus 2, 1 upon 2 plus 3 up to 2 upon m plus 1. This 2 will be in the numerator, will be equal to 2m upon m plus 1. Now as usual, you have to add the next term of this to the both the side. The next term of this will be 2 upon m plus 1, m plus 2. So adding 2 upon m plus 1, m plus 2, m plus 1, m plus 2 will be the next term of this. We have to add to both the sides of this. So adding this to the left hand side, adding this to the right hand side, and you have to simplify the right hand side only. You know it, we have discussed in the two questions. So by simplifying the right hand side, what should you obtain in the right hand side for m plus 1? You should obtain 2m plus 1 upon m plus 2 in the right hand side by simplifying these two terms. So add these two as usual. You can take 2 upon m plus 1 common, so it comes out to be m. 1 upon m plus 2, add these two, so you are getting m square 2m plus 1 upon m plus 2. You can factor this, it is m plus 1 whole square. So m plus 1 will be cancelled out by m plus 1, so it will be 2m plus 1 upon m plus 2, which is the next term of this, or which is the obtain the right hand side by replacing m by m plus 1 in the right hand side. So this is the next term of the right hand side. As usual, we are doing the questions. So therefore Pm plus 1 is true whenever Pm is true. Therefore Pn is true for all natural number by Pmi. These two lines you have to write in all the questions in this PMI chapter. Now in question number 4, also the same is the sum of this series is given, that is 1 into 2 into 3 plus 2 into 3 into 4 up to n plus 1, n plus 2 is equal to n plus 1, n plus 2, n plus 3 upon 4. You let that it is equal to Pn. Now we prove that it is true for n is equal to 1, to replace n by 1, p, or we can say that p1 means the sum of one term of the left hand side, which is equal to 1 into 2 into 3, which is equal to 6, which is equal to 6. And in the right hand side, replace n by 1, 1 plus 1, 1 plus 2, 1 plus 3 upon 4, which is equal to 6. So left hand side is equal to right hand side. It means this statement is true for n is equal to 1. Now again, let Pm is true, so it means the sum of m terms of this series or this statement will be equal to m plus 1, m plus 2, m plus 3 upon 4. That is, you have to replace n by m. So replace the terms n by m in the left hand side and right hand side. As usual, you have to add the next term of this to the both the side. The next term of this will be m plus 1, m plus 2, m plus 3. You have to add in the left hand side as well as in the right hand side of this, which is equal to this. You see it very carefully. We are getting m plus 1, m plus 2, m plus 3 common. So we are getting m upon 4 in this term and 1 in this. You add m plus 4 upon 4. You are getting this, which is the next term of this, or you can say we are obtaining in place of n, we are obtaining m plus 1, m plus 2, m plus 3, m plus 4 upon 4, which is the sum of this series for n is equal to m plus 1. So we can say that it is true for n is equal to m plus 1 whenever it is true for n is equal to m. Therefore, Pn is true for all natural number by the PMI. So it means, as you have seen in these two questions, main steps is the right hand side, and the main step is whenever you have to prove that it is true for n is equal to m plus 1. Most of the steps are there only for m plus 1, and main steps are also these. So main concentration should be there to the right hand side for m plus 1. So in question number 5, 1 into 3, 2 into 3 square, 3 into 3 cube up to n into 3 raised to power m is equal to 2n minus 1, 3 raised to power n plus 1 plus 3 upon 4 is the sum of these terms, which is equal to this. So again, let this equal to Pn. For n is equal to 1, it means the sum of the one term in the left hand side will be equal to 1 into 3, which is equal to 3. In the right hand side, the sum of one term replace n by 1. So 2 into 1 minus 1, 3 raised to power 1 plus 3 upon 4, which is coming out to be 3 in the right hand side and 3 in the left hand side also. It means this is true for n is equal to 1. As usual, we let that statement is true for n is equal to m. So simply you have to replace n by m, that is m into 3 raised to power m in the left hand side. In the right hand side, m 3 raised to power m plus 1 plus 3 upon 4. And you have to add the next term of this to the both side. So next term of this will be m plus 1. 3 raised to power m plus 1 is the next term of this. Adding this to the left hand side as well as in the right hand side. So adding this in the right hand side, I have obtained this, and as the main step is this, so be very careful. Now add these two. So first of all, add these two terms by taking the LCM 4. So it will be 4 here and 3 raised to power m plus 1 common in these two terms. See it very carefully. 3 raised to power m plus 1 is common in this term and this with 4 with it. So it is equal to 2m minus 1 into 4m plus 1. LCM adding these two terms first of all and then take common. Now simplify these two terms in the bracket, which is equal to 6m plus 3. 6m plus 3 and plus 3 upon 4 it is. Now you can take 3 common in these two terms. 3 common in these two terms. 3 common in these two terms. So what you are getting in these two terms, you are getting this 2m plus 1 into 3. So power will be added. Power will be added. When you take 3 common, 3 raised to power m plus 1 is already there. 3 common, when you take the power of that is 1. So it comes out to 3m plus 1 plus 1. In the bracket we have 2m plus 1 plus 3 upon 4. Now you can arrange it. For this, it is, you can write 3 raised to power m plus 1 in bracket plus 1. And for this, you can write 2m plus 1 minus 1. Because if we solve these two, you'll get this 2m plus 1. 2m plus 2 minus 1, which is equal to 2m plus 1 plus 3 upon 4. Why we have done this? Because you have to show that it is the next term of the right hand side. Which is this. This is for true for m is equal to n is equal to m. So you should obtain 3 raised to power m plus 1 plus 1, 2m plus 1 minus 1 plus 3 upon 4 for to be proved that it is true for n is equal to m plus 1. That is why I have arranged this. In place of 2m plus 1, I have written 2m plus 1 minus 1, which is equal to this bracket itself, 3 as it is. For this, simply I have replaced the bracket, which shows that it is the m plus 1th term. The sum of m plus 1 term rather. So Pm plus 1 is equal to this. So it is true for n is equal to m plus 1 whenever it is true for n is equal to m. Therefore, by PMI, Pn is true for all natural number. Now in question number 6, again the statement we have let it equal to Pn and the sum of these terms is equal to n, n plus 1, n plus 2 upon 3. For n is equal to 1, the left hand side is equal to 2. For n is equal to 1, the right hand side is also equal to 2. It means this statement is true for n is equal to 1, that is P1 is true. Again, let it is true for n is equal to m. So simply you have to replace n by m plus 1, m plus 1, m plus 1, m plus 2 upon 3. True for n is equal to m, we have to let it. Now again we have to let the next term of this to the both side, which is m plus 1, m plus 2 is the next term of this. M plus 1, m plus 2. Add this to the both the side. This we have added, and in the right hand side also I have added. And by adding these two terms, you should obtain m plus 1, m plus 2, m plus 3 upon 3, which is the next term of this. Concentration should be there for m plus 1, proving m plus 1 is true. This is the main step I was already told you in the last question. So what you are getting common? You are getting m plus 1, m plus 2 common. So m upon 3 plus 1 added m plus 3 upon 3, which is the next term of this. So we can say that it is true for n is equal to m plus 1 whenever it is true for n is equal to m. So we can say that Pn is true for all natural number n. So you must have seen that almost all the questions we are doing is same, and same steps are there. It may be some calculation part to prove that it is true for m plus 1 may be wrong, may be long, but the method is same in almost all the questions. We will discuss the next questions in the next lecture. Thank you.